Okay, so this is more help with Unit 11 Part D, E, and F CASTLE learning. So question 5 is kind of weird. Instead of showing you potential energy diagram and asking you to tell them about the parts, it just says that the energy released and absorbed during a chemical reaction are represented by a potential energy diagram. And that question actually is from 2018, so it is pretty new. So you never know what kind of weird thing they'll ask. I wasn't really expecting that. Question 6 says, given these scary looking equations, this is unfortunately also a pretty recent question. I think it's 2017. Which statement compares the energy for these two equations? So first of all, which one are they being energy absorbed or released? So for both of them, there's the kilojoules on the right in the products. So if energy is being produced as a product and not put in, so it's not being put in endothermic, this is definitely exothermic, and energy is definitely being released. So I'm going to pick one of these two where energy is being released. And then I got to pick, is equation 1 showing this much more times more energy, or is equation 2 showing this much times more energy? So I guess this number is the same. I just want to say which one's more energy. So it looks like this is a bigger number. 4.8 times 10 to the 8 is a bigger number than 2.2 times 10 to the third. So I'm going to say equation 1 has more. So I'm going to go ahead and pick choice 3. All right, so just really tricky sometimes the way they do this. So you just got to practice to get used to it. 7, sorry, it's so small. The diagram below, which one is exothermic? Okay, so this should be a nice, easy question for you. If it's exo, meaning energy exited, energy is released, it exited. So I should end up lower than I started because I lost energy along the way. I didn't gain it and end up with more than I started. I lost. Okay. So I'm just looking for a picture where it ends up lower than it started. And that is picture number 4. All right. So that'll definitely be a question you'll have to know. 8. What's the definition of heat of reaction? Again, it's supposed to be when you're figuring out how much profit your business made, you take your final, how much money you had in the end, say $400, and you have to subtract out how much money there was in the beginning. Oh, we spent $250, so we only profited $150. So you take the end and subtract the final. So product minus reactant. All right, so you'll definitely see that question. Given this equation, what's the net amount of energy released when 1 mole of H2O is produced? So I'm looking for this reaction making 1 mole of water. So I'm just going to go here and I'm looking for making water. Where are you making water? Just the way it was in the picture. Oh, there it is. It's on the is that it? We're on the very bottom. How do they want it? They want it to be H2 plus O2. Oops. H2 plus O2. Here it is. Okay. So see, it takes me a while too. So they want me to do H2 plus O2, making 2H2O. It looks like the number is 483.6. So, and they only said 1 mole, and this gives me how much to make 2 moles. So I'm going to say, okay, well, if it takes that much energy to make 2 moles, if I only need 1 mole, I only need half of that. So I'm going to divide that number, 483.6, divided by 2, and I should get like 240 something, I think. Oh, no, wait, 285 something. All right. So again, you might have to find an equation, but also divide it by 2 or something. At just regular old pressure and temperature, 1 mole sample of which compound absorbs the greatest amount of heat as the entire sample dissolves in water. So I'm looking for something that dissolves in water, and looking for absorbs the greatest amount. So if it absorbs energy, it's not releasing it, it's gaining it. So I'm looking for a positive number. I'm looking for the biggest positive number for these. So between these, I would just be looking on table H, which of those has the biggest positive number for its delta H on, table I. All right, and I will make one more video for those last 6 problems.